Hey there, we're going to be looking at rate of change. All right, so rate of change is what we're looking at. And you may want to grab a piece of paper because there's not a spot for this in the notes that I made for you. But rate of change. And we're going to first look at rate of change in a table. So this is IXL Q 15 perhaps. I'll look here in just a second. But we're looking at amounts that Mariana spent on lunch, and it says, according to the table, what was the rate of change between Wednesday and Thursday? So kind of like our unit pricing, right? Unit pricing, how we took the dollars, divided by how many days passed by. But now I want to know for the change between them. So that means we're going to subtract. So since it said Wednesday and Thursday, then I'm looking at these two numbers. So I'll take the second one minus the first one, because it did go up, right? So 6 minus 1. And then how many days between Wednesday and Thursday? Only one day. That's just one day that's passed. So then that's 5 over 1. And since it's a 1, that's already per day. So the rate of change then is $5. It changed $5 in one day. So per day. So per is like this would be in the bottom of a fraction. So $5 per day. So this is Q16, in case I misspoke and said 15 before. So Q16. So again, we have to pay attention to which periods we're talking about. So this says, because we've got lots of things here, but we have to make sure we're using the ones that they have mentioned. So 2008 and 2009. So we're talking about these two pieces of information. You want to take the later one, subtract the earlier one. So 78 subtract 86. And then how many years? That would just be 1 year, right? So I could still take the later one minus the earlier one. But I think we all know that that's just 1 year apart. Now, 78 minus 86. It is going to be important that we label this as a negative, because the school play actually went down between those 2 years. So since I have the bottom number as a 1, I don't need to worry about dividing. That -8 is going to be my answer. So -8. So it matters if the rate of change is going up or down, kind of like a price increasing or decreasing, it matters. So June and July, so again, find the two that you're given. The rate of change in these is not always the same from different points. So take the second one minus the first one. Hello, I don't know why I just wrote 20. How about if we try 72? And then how many months from June until July is just 1 month. So this is 2, and this time it is positive. So it's going up $2 per month. So far they have only been 1 day, 1 month apart. We're going to jump a level to see what we get next. So far this still seems the same. Between Tuesday and Wednesday, So Tuesday and Wednesday, I'm going to find both of those in our chart. There's Tuesday and Wednesday. So then that's 15 minus 15, because the change, I get the change by subtracting. So it didn't change at all over one day. So 0 voice messages per day. It doesn't mean that they're getting 0. It means how much it's changing. It didn't change at all during that time, so that's why it's 0. So here we get our first one that we're going to have a second step besides the subtraction. So this time we're using 2011, 2011, and 2013. So since it says per year, the years are what gets subtracted in the bottom. The later one, the second one is first when I subtract. That way I have positive years, like 2 years have passed. And this went from, so it's 17, it had been 18. So it went down 1 in 2 years. All right, so it went down 1 in 2 years. So that would be -1/2 or -0.5. I'm going to try, see if it likes a fraction. I'd rather I take that risk than you take that risk. -1 divided by 2. And that was just fine. Now, if that had been like 4 divided by 2, I would actually want to round, like to actually give an answer. This time I may have to round. It says round to the nearest tenth, so it could be messy. So March and June. So the second one goes first. So 77 minus 82. And then there's April, May, June, 3 months. Or I could think 6 minus 3. This is the 6th month, this is the 3rd month. So 77 minus 82, that's -5, divided by 3. When I see this that says round your answer to the nearest tenth, that tells me, oh, they don't want me to leave this one in a fraction. So I'm going to grab my handy dandy calculator and do 5 divided by 3. And I get a whole bunch of 6's and a 7 at the end. If I round it to the nearest tenth, that means I can only keep 1 decimal place. I look at the second, it's a 6, so it's going to bump that up to 1.7. And it's still negative. If you're afraid you'll forget the negative, then type -5 in your calculator. So -1.7. So we want to know the rate of change between Monday and Thursday. So here's Monday. Here's Thursday. I don't worry about what happened the other days. I only worry about these two. The second one goes first. So 2 take away 7. And that makes sense because that tells us it's gone down 5. Now, you might just do 7 minus 2 and then say it got lower, so I know it's -5. That works too. And then how many days? So Tuesday, Wednesday, Thursday. So we don't count the day we're starting on. We count how many days have passed. So like how many jumps? 1, 2, 3 jumps. So that sure looks a little familiar, I think. We got 5 divided by 3 again, And again, it's supposed to be to the nearest tenth. So I've got that 1.6 repeating, which to the nearest tenth is again going to be negative 1.7. So 1.666, etc., etc. If I can only keep one, I look at this one. It's a 5 or higher, which tells me this guy is going to get bumped up to be 1.7. So it's closer to 1.7 than it is to 1.6 because it's more than halfway. And it is negative, so negative 1.7 again. This time we're supposed to round to the nearest cent. So now we're going to keep 2 decimal places because it's money. And the rate of change between June and September. So here's June. Hello. Here's June. Here's September. Subtract. And then how many months passed? 1, 2, 3. So now I have 32 over 3. And it actually went higher this time, so it is positive. Grab my calculator, I get 10.666 repeating. So if I've got 10.666, here's my point, 7 out here, I can only keep 2 places. This third one is going to tell this guy to round up. So $10.67 per month. That's the rate of change. That's how it's, on average, it's going up $10.67 per month. So I subtracted the money, divided by the number of months that had passed, rounded my answer. So that's rate of change from a table. So very much real life application things there. And then rate of change from graphs. If it will let me show you, maybe. I must be clicking my... Goodness. I feel like I'm doing the right thing here. And it just wants to show me the shortcut. All right, well, let's try this again. So, Q17. Oh my goodness. All right, it was a labor, but I finally got it to open. I had to go a backdoor way. So, here we go. So now we have a graph. And we're doing the same thing, but now we're given the dates and we're given the information in a graph. So I see here they want to know between 2008 and 2009. So there's 2008, there's 2009. Now, since only 1 year has passed, we just need to figure out how much the students went up or down. And I think we can all see that it went up. And then if I do 90, take away 55, then that would be 35. And it's just in 1 year, so I don't have a division step. So just 35. So annoying. So from 2010 to 2012. So this time, talking about this point and this point. We don't have to worry about the point in between them. We're looking for the rate of change between those 2 years. So 2012, it's 32. 2010, it's 24. And there's 2 years between 2010 and 2012. So then that's 8 divided by 2. And it is going up, so that's a positive 4 vacation days per year. That's the rate of change. So here between 2013 and 2014, so it's gone from 10 to 16, so it went up by 6 in just 1 year. So that would just be straight up 6. So this time between 2016 and 2018. So 2016, it was 45. 2018, it's 20. So we would want to do the 20 minus the 45. And that would be over the course of 2 years. So I'm going to say negative 12.5. So it changed by 12.5 games per year. Negative 12.5. So if the later date is lower than the earlier date, then you should see that your rate of change is negative. So this one is one we'll have to round. It says kilograms per year to the nearest tenth. 2016 is at 50. 2019 is all the way here at 100. So remember, second one goes first. So 100 minus 50. And then that's 3 years when I subtract those years. So negative 50 divided by 3, that's going to be negative 16.7. Round it to the nearest tenth. All right, so just make sure you're zoning in on the right information by the dates or the days of the week that they've given you. And sometimes you're just going to be subtracting. Sometimes you're going to subtract and then divide. And that is, that will finish up the things that we're doing in the Qs. Again, that was Q16 and Q17. And so you pause the video, go do Q16 and Q17, and then I'm going to tell you about slope, which does kind of pick up in your notes. All right, I hope you were your awesome self and did great on those 2 lessons about rate of change. And speaking of rate of change, if you look at this slide, and this is in your notes, you're going to see rate of change right down here on the middle, because rate of change really is slope. Okay, so when we're talking about those rate of change for problems that are applications, typically the X value is some length of time, like per day, per hour, per week. And the Y was like the number of people or the price, and it was going up or down, right? And so we subtracted on the top. Remember, we took the second coordinate, the second number first, subtract the first one, and then we found out the change in the time on the bottom. Sometimes we didn't have to write that down. We could just like, oh, that's only 1 day from Monday to Tuesday. So that same thing works for a graph. And so we're going to be looking at finding the slope of a graph that are going to be where the rate of change is the same. These are going to be linear, like one straight line. And so you're going to hear me talk about the rise over the run. So when we graph something, we go X left and right first, Y up and down. But when we're talking about slope, the Y's have to be subtracted on top. The change in the y coordinates is on top, the change in the x coordinates is on the bottom. So we're looking at how much does it go up and down? That's the vertical change, compared to how much does it go side to side. This delta means change. All right. So let's look at IXL, and we're going to be in the S's. We're going to be camped out in the S's pretty much the rest of the week, if I recall correctly. And this is S3, yes, S3, finding the slope of this graph. Now, the trickiest thing is going to be, it doesn't tell you specific points to use. You have to choose what points to use, but you need to choose points that you know exactly where they are. So we have to be sure that when we're choosing the points to count between, that we are choosing perfect corners. So for instance, this is a point because it's right at a perfect corner. Not a point, not a point, not a point. That is another point. And then that's the points I'm going to count between. So between those 2 points, how much does it go up? Well, it's going up 1, 2, 3 boxes. Or I could think it's going from 0 to 30, right? From 0 to 30. So it's going up 1, 2, 3. And then how much is it going over? 1, 2. So if you, and they're both 10s on both sides. So if instead I want it, I could have done 30 minus 0 on the top. And on the bottom, I could have done 70 minus 50. And that's still 30 over 20, and then it reduces to 3 over 2. And we want to be sure when it says simplify your answer, that means even if you did it this way I did at the top, you need to reduce that fraction down to 3 over 2. But if you have a graph, just counting the boxes is going to be the simplest way. So again, when I did that, I'm just counting, I'm making sure that I'm looking from a perfect corner to another perfect corner. Now, you might see more than 2 perfect corners. Here's another perfect corner. But notice, what if I chose this one and this one? It still goes up 3, 1, 2, 3, right? 1, 2, 3, and over 1, 2. So it's still 3 over 2. So if it's a straight line, if it's linear, the rate of change stays the same. It doesn't jump, zigzag and change. It's constant, has a constant rate of change. So we're just basically counting the boxes after we find nice perfect corners. So this was 3 over 2. Oh, stop. That's the same question, 3/2. So use your slash button to do your fraction. So again, I have to find perfect corners. So this time, my perfect corner, I can't use right at the axis, and it doesn't touch the x-axis, but there's a nice perfect corner. And the next one I see is here. So between those two, it's going up 1 and over 2. Now, I can check that. If I continue along the line, it should continue going up 1 over 2. Up 1 over 2, still on the line. Up 1 over 2. Up 1 over 2. So if I do that, and then like the line isn't really in that spot, it means I didn't read one of my dots well. But it does, so we're in good shape in this case. So that would be 1/2. 1 over 2. So the slope can be steep. Those were pretty flat. This one is steep. Closer to going straight up. Again, I have to find perfect corners. So there's one at 2, 2. And then I'm moving along the line, looking for the next time I see a perfect corner, which appears to be there. So to get from the bottom corner, the first corner I had, to the next perfect corner, it's going up 1, 2, 3, 4 boxes and over 1. Now, because this is over 1, I can just type in 4. So any number over 1 is the same as that number as a whole number. So that would be 4. We can have negative slope. Let's see if I jump a level if we get a negative slope. Nope. I just started putting some bigger numbers and the full coordinate plane. I still need to find 2 perfect corners. Sometimes it's going to be harder to find perfect corners. Like some of them look like, well, maybe. In this case, this guy down here is a perfect corner. And then 2, 2. Now, here's the thing. If I think that this is another corner, if I think it's going up 3 over 1, and I try to go up 3 over 1 again, when I get to the next one, that didn't work. So that means my first one wasn't actually right. So if it seems close, but then when I try to carry it out, it doesn't work. So this one, and then my next one is almost. I believe my next one is up here under this 60. So that's actually going up 8 boxes and over 3. Or you could put 8 over 30, but it would still turn out to be 8 over 3. Now if I want to test that from this dot, if I go up 8 and over 3 again, I should be right on the line. So up 8 and over 3. So it did work, right? So if it seems really close, you might want to zoom in so you can see if it's really at the corner, or try plotting a second point, like carrying the slope on again, to see if it works, because that's how I knew that it did not work when I tried just 4 over 1 or 3 over 1. So 8 over 3. 8 over 3. And they don't want those as decimals, they want them as fractions, but the fractions should be reduced. Well, surely I'll get one negative. Maybe not. Maybe you won't see any negatives. That one actually gets easier. S4, now you're going to use, in S4, you're going to use the formula that is on your notes. So let's look back at our notes. We're going to use this formula up here at the top that says y2 minus y1 over x2 minus x1. And I've got some examples here for us. Get this big enough to see. So when I look at these points, I have 9, 11, whoa, 9, 11, and I have negative 6, negative 14. So I'm just going to write those the two ordered pairs nice and big. When I look at them, remember in each one, the first number is an x. So this is, we're going to call this guy x1 and this x2. So it just means the first x and the second x. It does not mean we're squaring the x's. And this would be y1, and this would be y2. So now I'm going to take that second y, subtract the first y. The y's get subtracted on the top. Remember the formula from your page. And m is typically used to represent slope. I think because of a Latin word. And then in the bottom are x's. And this is 9 subtract negative 6. Following our sign number rules, we get negative 25 over positive 15. And then when we reduce, we have negative 5 thirds. Because 5 goes into both of those. 5 goes into 25 5 times. 5 goes into 15 3 times. By the way, if you did the problem and you took the 11 first, if you did 11 minus negative 14, and then you did 9 minus negative 6, I'm looking because I must have screwed something up back here, because I should come up the same. I switched things. Dang it. So rewind on that, baby. I don't know if I'm gonna. I don't have time for editing, friends. I jacked this part up. How did I jack it up? So think about this. How did I jack it up? I jacked it up because I was subtracting the x's, but this says to take x2 first, and I took it in the wrong order. So this should have been, it's the end of my day, I guess it's time to go home. Negative 6 subtract 9, which is going to make these both negative, which makes my final answer positive. Now, could I take the 9 first? Well, I could take the 9 first, but if I'm taking the 9 first, I needed to have taken his partner, the 11, first in the top. Because there's nothing really magical about which one you're calling the first point or the second point. But once you call it first or second, the y has to be the same. The x and the y have to be the same. So if I take the negative 14 first on top, then I have to take negative 6 first on bottom because he's his partner. So learn from my mistakes. I'd love to say that I made that mistake on purpose, but nope, I didn't. That wasn't planned. So same thing over here at the right. I'm going to do 0 minus 5, so my second y minus my first y on the top, negative 17, subtract negative 18 on the bottom. There is a subtraction sign in the formula. So if you're also subtracting a negative, we end up with this subtract a negative, double negative, that turns into plus. So this turns into negative 5 on top, 0 minus 5, and then negative 17 plus 18 is a positive 1. So if it's just a 1 on the bottom, the slope can just be expressed as a whole number, or as an integer, I should say. And that is the process that you're going to do in S4. They're going to give you two ordered pairs. You're going to subtract the y's on top, subtract the x's on the bottom, and simplify. All right, so I may have been ambitious to have also scheduled slope-intercept form. We'll see how Tuesday goes. But we will for sure have talked about rate of change and slope, which are basically the same thing, just rate of change is more application related. All right, thanks and good luck with those 4 lessons.